Parabola y is equal to negative 3x squared plus 9x intersects with the line y is equal to negative 3x plus 9 in the point A and B on the quadratic function. Solve for the maximum point of P, which makes the maximum area of the triangle ABP. Quadratic functions over the coordinate plane, there are two kinds of graphs. First graph is y is equal to negative 3x squared plus 9x, which is a quadratic function, which means when you graph it, it will going to be a parabola. Second one is a straight line, which we usually call it as linear function, which satisfy our y is equal to negative 3x plus 9. Before you solve for this question, let's think about one of the most important things when it comes to solve for this question, type of our quadratic function. In the case of a quadratic function, both of the case of quadratic functions are defined by the leading coefficient of a quadratic function. So at first, we notated leading coefficient as a, and the first case will going to be when the a value is equal to positive. So when the a value, which will going to be our leading coefficient, is greater than 0, the graph of our quadratic function will go upward. If you think about the quadratic function going upward, for example, it will look something like this that keeps going upward. But then it will going to contain a specific point that we want to find usually, and is one of the most important thing in a quadratic function. It will going to be a minimum point. For that minimum point, we also call it as the lowest point of the graph. And this is what the minimum point is. And this is defined when the a value, which we notated as leading coefficient, is positive value. The second case, or the second type of our quadratic function, is a case when the leading coefficient is negative, which means when it is less than 0, the graph of our function will go downward. When a quadratic function's graph goes downward, for example, it will look something like this. That is opposite formation of our first one. And then it will going to contain a specific one point, which will going to be the maximum point of our graph, unlike the first one. For a maximum point, we usually call it as highest point on our graph. And it is defined when the a value, our leading coefficient, is negative value. And if you think about the term of the vertex of our function, the vertex of the function is same thing with addition of both number possibilities of our uppercase, which we call it as minimum point, and the number possibility of our when the a value is less than 0, which we're gonna inform or deform a maximum point. This is what the vertex concept is. Our quadratic function y is equal to negative 3x squared plus 9x. According to this property, the leading coefficient will going to be negative 3, which is clearly less than 0, which means negative 3 is a negative value, so the graph of our quadratic function will only contain a maximum point, which will going to be the highest point on the graph, and the graph formation will go downward. That's the information about the point A and B. And the point A and B is the intersection between these two quadratic functions and the linear function. So let's solve for its coordinate. At first, let's solve for B because it's easy to solve it through visually. And if you think about the position of the B, it is the intersection between these two quadratic functions and the linear function. and is unknown in the x-intercept. And if you think about the definition of the x-intercept, x-intercept is the case where the x-coordinate exists. We notate it as x because it's a variable, and our y value should always be equal to 0. So that means when the y value is equal to 0, our input of our function exists. This is what the x-intercept means. So in order to solve for the x-intercept, all we have to do is we need to input our y value as 0. So at first, we can put any of our quadratic function or the either quadratic function or the linear function because this point should satisfy both of our equations. So at first, let's simply choose y is equal to negative 3x plus 9 for the convenience. And for y is equal to negative 3x plus 9, let's do it in the second page, where y, our linear functions, y is equal to negative 3x plus 9. And for the x-intercept, it is always the case where the y value is equal to 0. So we can set y value as 0, and that is equal to negative 3x plus 9. All we did is we changed our output of our function, which we usually notated as y, into 0. So now all we have to do is we can subtract 9 to the both sides in order to isolate the x terms. So we're going to get negative 9 is equal to negative 3x. In order to solve for the x value, all you have to do is we need to divide every side into negative 3, which we're going to get x is equal to 3. So we can relate this to our quadratic functions graph or the coordinate that when the y value is equal to 0, our y value will going to turn into 3. And the 3 comma 0 will going to be the b value, so we can write our b value or the coordinate as 3 comma 0. But if you think about the point A, there is no way to solve for it because it is not in either y or the x-intercepts. But if you think about the point A is a point or the coordinate on the quadratic function and both linear function, which means this point A satisfies our quadratic function's equation and our linear function's equation. Which means if we use elimination equations to solve for our like solutions for our both functions, we're gonna get it. But then we're gonna get two answers because there is two intersections A and B. But we don't have to worry about B because we already got it through our y and the x-intercept property. So at first, let's write our two quadratic function down. Two quadratic function and the linear function. Y is equal to negative 3x squared plus 9x, and then y is equal to negative 3x plus 9. Only way to use elimination equation only case is that one of the sides are same. But if you look at it, they all contains a y value, which means they are all same. So which means this one is also y, this one is also y. So all you have to do right now is we need to use a elimination equation by setting them equal. So negative 3x squared plus 9x is equal to negative 3x plus 9. And the only reason why we could do it is because the left side were equal. So all we have to do now is isolate the x terms into left side and also the constant into the left side, And then if we do that, we're going to make one side is equal to 0. So we can find the solutions of our quadratic function eventually. So if you write our quadratic function down again, negative 3x squared plus 9x is equal to negative 3x plus 9. All you have to do is we can add or subtract left terms, which we're going to get negative 3x squared. And then I'll use a different color for it. So plus 9x plus 3x, we're going to be 12x. And then if we subtract 9, we also need to subtract 9 here. And then we're going to make 0. And now, since we knew that it became a one quadratic function, we can solve for its solution. And as the way of solving for the solution, we need to convert this into a binomial form. But then all of these terms are divisible by negative 3. The reason why we divide them into negative 3 is because the leading coefficient is not equal to 1, which means it will gonna hurt to calculate. So if we divide all terms into negative 3, we're going to get x squared minus 3x, and then plus 3. Even though we divide 0 into negative 3, we're still going to get 0. So if we convert this into a binomial form, it will look something like this. So there will be two x's, which makes x squared if we multiply. And for the unknown quantity that I'm pointing out, if we multiply together, we need to get 3. And if we add it, we need to get negative 3. But then if we got a mistake here, it should be negative 4x. So if we multiply, we need to get 3. If we add, we need to get negative 4, which we can simply get it as x minus 1 and x minus 3. So this will going to be our quadratic functions binomial form, but then that is equal to 0. If you multiply both of them equal and it is equal to 0, which means one of them should be equal to 0. So we're having a two cases. At first, when the x minus 1 makes equal to 0. And the second case, when the x minus 3 makes equal to 0. We can simply add 1 to the both sides to isolate the x term, which we're going to get x is equal to 1. For the second one, we can add 3 to the both sides, which we're going to get x is equal to 3. So these are going to be the x-coordinate of our intersection point. So at first, if you look at our x is equal to 3, we already solved for it. X is equal to 3, which will going to be our point B. And if you think about x is equal to 1, it will going to be our x coordinate, not a y coordinate. In order to solve for our y coordinate, we know that x, so if you write it down, x coordinate will going to be the input of our function, and the y value is our output of our function. Which means if we found the input of our quadratic function, all you have to do is we need to input it back to our equation or the functions to get our original output. So, but we need to know that both of them satisfy our two functions. So all you have to do is we can choose either one of them. So at first, if you choose the easy one, which will going to be our linear function, y is equal to negative 3x plus 9. If you input 1 to our x value, we're going to get y is equal to negative 3 plus 9. So plus 9, which we're going to give us the output 6. So our y value, y coordinate of our a, we're going to turn into 6. So our a turn into 1 comma 6, b will turn into 3 comma 0. But if we think about the parallel in our linear function, it is same thing with the same slope, but with the different y-intercept. And the y-intercept will going to be a constant. So for our by solving for a point P, and which will going to be included by our new function, and if we write our original function down, y is equal to negative 3x plus 9x, so plus 9. Our constant should be different, but with the same slope. So we can just set our constant, which will going to be our y-intercept, simply as k, because it will going to be the constant without any variables. Step of solving for a point P, and most importantly, point P is on our quadratic function y is equal to negative 3x squared plus 9x, and then it should then in the point, or it should be the line, and the line that satisfies our point P should be parallel with our linear function y is equal to negative 3x plus 9, which means our quadratic function it should be contained from our quadratic function, and our new linear function should be parallel with our original linear function, which will going to be y is equal to negative 3x plus 9. And then the point P, which makes our triangle A, B, and then P somewhere else in our quadratic function into the maximum area. We need to solve for the value of the k, because it will going to be our point P's coordinate. And for our current coordinate, the most important thing when it comes to solving for our k value is that we can use our information that this line or the linear function is an our quadratic function. So our quadratic function was y is equal to negative 3x squared plus 9x. And then same thing as we did here to find our a or b values. All we have to do is we need to use our elimination equation to solve our variables or unknown variables. And the most important thing when it comes to solving for the elimination or applying it is that one side should always be equal. And in this case, left side are y, which we're going to be same. So as our step here, all you have to do is y are same, so we don't have to write it down. So we can simply set the both sides equal. So negative 3x plus k is equal to negative 3. So that is equal to negative 3x squared plus 9x. So from here, we will be able to solve for a k value. We can simply say that our solving for the k we're going to be same thing with solving for the solution of our function. But solving for a solution is same thing with as a step of making one side or the y as 0. And actually solution was same thing with the x-intercept. This is what the solution means. So all you have to do is we need to isolate one term, one side equal to 0. And all you have to do is we need to use addition or subtraction to do that. So if you write our function down again, negative 3x squared, so squared plus 9x is equal to negative 3x plus k. So now we can add 3x to the both side and then subtract k to the both side. Now we're going to get our final step where we have negative 3x squared plus 9x, positive 9x plus 3x will going to be plus 12x. We still have negative k. And then finally we have the one side equal to 0. Once I move this right side to our left side a little bit for more spaces. Point P will going to be the maximum point, which means from here we could have just solved for our by So for our k value by making this into binomial form, but then you want to take us less of time. Maximum or minimum point, it is more efficient if we convert this into a vertex form. And the vertex form is optimized when it comes to solving for the vertex. And if you think about the definition of the vertex, it is the same thing with adding number of possibilities of minimum and the maximum points of a quadratic function. So this is what the vertex form does. So at first, if you think about the normal form, a vertex form will going to be a times x minus p squared plus q. And if you think about the a value, it is also the leading coefficient like here. And for the p value, it will going to be our x coordinate of our quadratic function's vertex. Q will going to be our y coordinate. This is what the vertex form is. And if we actually apply it, so from the negative 3x squared plus 9x, so it will going to be 12x minus k, and that should be equal to y. Making into vertex form is same thing with converting it into a completing square form. So at first we can take out every single term by negative 3. Let's think about other ways of solving for the k value. So first, solving for a k value, there is one more term. Another way to do it is to use our um let's use our solution formula, which is the most efficient thing to solve for k. The only thing that we need to care about is inside the radical from our live videos, b squared minus 4ac. And then if you think about the b terms, our b terms will going to be the first power coefficient, which will going to be the square root of b. What is b squared? And the b squared will going to be so our second term will going to be 12 and then square. The minus 4 times a is the leading coefficient, which will going to be positive 3, so we'll turn to positive 12. But then we're multiplying our c, which is a constant, and it will going to be k. But we don't know the k value, so we're going to be negative 12k. But then that should be equal to 0. So right now we don't really have to care about the radical. So we can just take this up and say 144 minus 12k is equal to 0. The reason is because we're not trying to find our solutions, we're trying to find the value of the k. So all you have to do is we need to subtract 144 to the both sides in order to isolate the k term. And negative 12k is equal to negative 144. So we can get k is equal to 12. So this is what the k value will going to become. So if you write our full function down, it will going to be negative 3x squared plus 12x minus 12. That is equal to 0. This is what our full function is. We found the k value through our solution formula. And here we can use our p value. And in order to do that, all you have to do is convert it into a vertex form. So at first, our full function was negative 3x squared plus 12x plus 12 minus 12 is equal to 0. All you have to do is we need to take out negative 3 from the terms. So x squared minus 4x and then plus 4. That should be equal to 0. And then we can say the negative 3 will going to be our a value, which will going to be the leading coefficient in our function. So it will going to be negative 3 times x minus 2 squared, and that is equal to 0. Or you can just set it as y because we are converting into our original function. And then we can say that our p value will going to be 2, as we're learning a lot of videos. And for the q value, there is some q values, but then they didn't really give us, they didn't expose us our q value. But we don't really have to worry because our x value is the input, which means we can input our function, our x values, to one of our function to get our q or the y value. So q will going to become, let's choose a line 1, which is easy. Y is equal to negative 3x plus 9. All you have to do is we need to input x value as 2, which we're going to get 9. Y is equal to negative 6 plus 9. The reason why we can apply to our lines because we created our vertex form through our quadratic function, which means our vertex form won't satisfy our line. So we only need to use our quadratic form, which will going to be, so y is equal to, we need to input x value as 2, which will going to give us negative 3x squared will turn to 4 into negative 12 plus 18, which will going to give us 6. So we can say that our x value, our point P will going to be 2, and then point y value will going to be 6. But we're not done yet. Our ultimate question was solved for the point, which will going to be a coordinate. So we can simply say that our right answer here. So our answer for this question will going to be, so the x value is 2 and our y value will going to be 6. And this will going to be our point P's coordinate.